This is Radhika. I am going to discuss about the power electronic subject for electrical 5th sem students. Before we are discussed so many classes regarding power electronics. Now we are going to discuss about the cycloconverters. Under that, today we are going to discuss about the single phase center tapped cycloconverter. Single phase center tapped cycloconverter. So, in previous class, we discussed about the working principle of simple single phase cycloconverter. Actually, in last class, we discussed the cycloconverters basics and working principle and step up and step down. So, actually, just now I'm going to discuss briefly about cycloconverters. Now, actually, what is cycloconverter? A device which converts input power at one frequency to output power at a different frequency with one stage conversion is called cycloconverter. So, cycloconverters are mainly of two types, that are step down cycloconverters and step up cycloconverters. So, here it is step down cycloconverters. The converter, it converts the output frequency F0 is lower than the supply frequency Fs, means F0 less than Fs. In step up cycloconverters, the converters, it converts the output frequency F0 is more than the supply frequency Fs, means F0 greater than Fs. The converters also, it will be used in speed control of high power AC drives, in induction heating. It also used in static VR generation, used in electric traction, aircraft and shipboards power supplies, HVDC transmission system. It will be used in cement mills, ball mills, etc., and also used in mine hoist and grinding and rolling mills. And also it will be used in so many applications. So today's objectives are: on completion of this period, you would able to know the topics are construction and the principle of single phase center tapped cycloconverter, circuit diagram and output waveform of cycloconverters. These are the main topic about the cycloconverters after discussion of single phase center tapped cycloconverters. So here, so in this, so in this topic today, so we are going to discuss about the single phase center tapped cycloconverter. Here, the secondary winding of a transformer is provided with the center tappings. It consists of four thyristors. Two of these thyristors, P1 and P2, are formed the positive group, and the other two, N1 and N2, are formed the negative group of, as shown in the circuit diagram. I will show you. And also the load is connected between secondary winding midpoint O and terminal A. So this is the diagram for single phase center tapped cycloconverter. In this, the single phase center tapped cycloconverter using step up transformer. In this type, the secondary winding of the transformer is provided with center tappings. It consists of four thyristors. Two of these thyristors, P1, P2, are formed as positive group, and the other two, N1 and N2, are formed as negative group. The load is connected between secondary winding, midpoint O and terminal A. So in this diagram we have the P1 and N1 thyristor in above and P2 and N2 thyristors in below. Here P1 and P2 are the positive thyristors and N1 N2 as the negative group thyristors. And also it has this is the center tapped and the voltage is supply voltage Vs, and here this is the midpoint and we have the small a and small b terminals, and also we have the capital A, and the load current will be flow from load here. From this figure, during the positive half cycle of the supply voltage, terminal A is positive with respect to terminal B. Therefore, the thyristor P1 and N2 are forward biased from omega t is equal to 0 to omega t is equal to pi. In this diagram, in this waveform, during the positive half cycle, the supply voltage terminal A is positive with respect to terminal B. Therefore, the thyristor P1 and N2 are forward biased from omega t is equal to 0 to omega t is equal to pi. If the thyristor P1 is turned on at omega t is equal to 0, here omega t is equal to 0, so that the load voltage is positive with the terminal and O is negative. Therefore, the load voltage now follow the positive voltage, sorry, therefore the load voltage now follows the positive envelope of the supply voltage. At instant Wt is equal to 1, here W2 is equal to 1, P1 is force commutated and the other forward biased thyristor N2 is turned on, so that load voltage is negative with the terminal O positive and A negative. Hence, the output voltage waveform now traces the negative envelope of the supply voltage. At instant W2, the thyristor N2 is force commutated and P1 is turned on, causes the load voltage is now traces the positive envelope here. And also it has the at after omega t is equal to pi, omega t is equal to pi, terminal B is terminal small b is positive with respect to terminal A. Both thyristors P2 and N1 are forward biased from Wt is equal to pi to 2 pi. At omega t is equal to pi, the thyristor N2 is forced commutated and forward biased thyristor P2 is turned on. At omega t, that is equal to 1 by 2 fs plus 1 by 2 f naught. Here P2 is forced commutated and forward biased thyristor N1 is turned on. Hence, from the above thyristor P1 and N2 are switched on alternatively during positive half cycle, and the thyristor P2 N1 are switched on alternatively during negative half cycle. From this figure, the output frequency F naught is higher than the supply frequency Fs. So here the output frequency F naught is equal to 6 Fs. So so in this cycloconverters, this is the diagram for saddle tapped cycloconverter. Here the supply voltage, source voltage, and here it is the center tapping, and here is the primary and secondary. So this is the primary and it is the secondary. This secondary has the center tap, and it has the small a and small b terminals, and the small a terminal will be connected the P1 and N1. These are the positive and negative group thyristors. And also here for point B, terminal B, it will be connected to P2 and N2, positive and negative group of thyristors. And also it has the load, it will be output voltage V0, and here also it has the output current, and here is the terminal A. And when in positive half cycle, the P1 here from positive A to it will be conducts P1, and it comes to at a time P1 and N2 will be conducts, and also in negative terminal P2 and N1 will be conducts here. In positive half cycle, in first envelope, this is called one envelope. This circle oval shape is called one envelope. In one envelope it will be conducted P1 and N2. So here for the at omega t is equal to 0, it will be conducted first positive P1, and it will be forcefully commutated, and it will comes to 0. Here omega t is equal to 1, and it will be N2 will be conducted, and it goes to some place, and at omega t it will be turned off forcefully, and again the P1 will be conducted. Likewise the first envelope will be formed. In next envelope, when Wt is equal to pi, that time the P2 and N1 will be conducted. In positive half cycle, the P2 will be conducted, and at some time with forced commutation it will be falls to 0, and next the N1 will be conducted. After that time it will be also turn off using a force commutation, and next the P2 will be conducted. Likewise the second envelope will be formed, the second envelope will be formed. Likewise the envelopes will be formed again and again. In this, during the negative half cycle of supply voltage, terminal A is positive with respect to terminal B. The thyristor P1 and N1 are forward biased from omega t is equal to 0 to omega t is equal to pi. If the thyristor P1 is turned on at omega t is equal to 0 degrees, so that the voltage is positive with terminal O, the load voltage now follows the positive envelope of the supply voltage. And also at instant Wt is equal to Wt1, P1 is force commutated, and the other forward biased thyristor Nt is turned on, so that load voltage is negative terminal, O positive, A is negative. Hence the output voltage waveform now traces the negative envelope of the supply voltage. At instant WT, WT, WT2, thyristor N2 is forced commutated and P1 is turned on, causes the load voltage is now traces the positive envelope. And also after WT is equal to P, terminal B is positive with respect to terminal A. Both thyristors P2 and N1 are forward biased from WT is equal to pi to 2 pi. Here WT is pi, the thyristor N2 is forced commutated and forward biased thyristor N1 is turned on. Here at omega t, that is equal to 1 by 2f 2fs plus fs means supply frequency plus 1 by 2 f naught. F naught means output frequency, fs is the input frequency. Here P2 is forced commutated and forward biased thyristor N1 is turned on. The above transistor P1 N2 are switched on alternatively during negative half cycle. The output frequency F0 is higher than supply frequency Fs. So that will be F0 is equal to 6 Fs. And now we will watch one YouTube lecture about single phase center tapped cyclo converter.
Converters. You can also see that the circuit diagram. Hello, today we will discuss the step down type cycloconverters. What are step down cycloconverters? Step down cycloconverters are those in which the output frequency is less than input frequency. Like in case of step up cycloconverters, we have discussed midpoint type cycloconverter and bridge type cycloconverter. Here also we have two types, that is midpoint type cycloconverter and second one is bridge type cycloconverters. You can also see that the circuit diagram for midpoint type cycle converter in step up cycle converter and in step down cycle converter will remain same. As the circuit diagram is same, but the working of this circuit diagram will little bit vary. So in this circuit diagram we have four thyristors, that is thyristor T1, T2, T3 and T4. Like in case of step up cycle converter, in midpoint type we have a input transformer. This transformer is a center tap transformer having a center point denoted by point K and two extreme points which are point A and point B. In this step down midpoint type cycloconverter, the thyristor T1 will work for first positive half cycle and the thyristor T4 will work for second positive half cycle. The thyristor T3 will work for first negative half cycle and the thyristor T2 will work for second negative half cycle. Before discussing the working of this cycloconverter, the working of this circuit diagram, we will first move towards the waveform of this step down cycloconverter. This is the waveform of step down type cycloconverter. In this waveform, we can see that Vs is the input waveform having number of cycle equals to 2 in a given time interval, having alternate positive and negative pulses. If we want to reduce the input frequency, that is to step down the input frequency, we just have to reduce the number of cycle. That is, in the output waveform we can see that the full cycle from input is got converted into a positive peak, and a second full cycle from input is got converted into negative peak. So we have stepped down the frequency coming from the input. Now how it is to be done? In the first input cycle, the negative pulse of the first input cycle is just to be converted into a positive pulse, and the positive pulse from second cycle is just to be converted into negative pulse. So by doing this process, we just reduces the number of cycle. The another important thing is that during the first positive half cycle, the thyristor T1 will work. During the second positive half cycle, thyristor T4 will work. During the first negative half cycle, thyristor T3 will work, and during the second negative half cycle, thyristor T2 will work. The output from these pulses will be the average output of the positive pulse and the average output of the negative pulse. Now we will discuss the working of a circuit diagram. As we have studied the input waveform having alternate positive and negative pulses, so during the first positive pulse, the terminal A will be at positive potential, terminal K will have alternate negative and potential at center tap point, and the terminal V will be at negative potential. Due to positive potential at point A, thyristor T will be forward biased and it starts conducting. So the current starts flowing from positive potential through the thyristor T1 through the load to the negative potential like this. During the first negative pulse, the potential at different point, that is at point A, at point K and point V, will be reversed. That is, at point A the potential will be negative, at point K the potential will be like this, and potential at B will be like this. Due to positive potential at point B, due to positive potential at point B during the negative pulse, the thyristor T3 will be forward biased. So the current from point B, that is from positive potential through the thyristor T3 and through the load, will start flowing like this. So the current from positive potential will ends at the negative potential. So what we have seen, during the first positive and negative potential, the current through the load remains the same. That is, the current through the load remains the positive. So we have just converted a full input half cycle into a positive cycle. During the next positive half cycle, during the next positive half cycle, again the terminal A will be positive, K will be like this, and B will be at negative potential. Due to this, the thyristor T4 will be forward biased as it is connected in opposite direction. So due to negative potential at point B, it will be forward biased. Now the current will flow from positive potential to negative potential like this. From positive potential through the load and through the thyristor will ends at the negative potential at point B. Now during the second negative half cycle, the potential at different point will be reversed. That is, at point A the potential will be negative, point K the potential will be like this, and at point B potential will be at positive potential. Due to this, the T2 thyristor T2 will be forward bias as it is connected in reverse direction, and due to the negative potential at at point A, thyristor T2 will be forward bias. So the current through the load through the thyristor T2 will flow like this. In this case also, what we have seen, the current through the load flows in the opposite direction as discussed in the first cycle. So the current through this cycle will be negative. So we have seen that during the two full cycle, in the first full cycle the current through the load flow in one direction, and during the next full cycle the current flow in the opposite direction, that is in the negative direction. So we have converted two number of cycles into a single cycle. So we have converted, we have just stepped down, we have just reduces the input frequency. Thank you.
Hi all, today we are going to
So this is about single phase center sap cycloconverter. So in this step up cycloconverters, the single phase center tapped cycloconverter using step up transformer. In this type, the secondary winding of the transformer is provided with center tappings and center tappings. It consists of four thyristors. Two of these thyristors P1, P2 are formed as positive group, and the other two N1, N2 are formed as negative group. The load is connected between secondary winding midpoint O and terminal A. During the positive half cycle of supply voltage, terminal A is positive with respect to terminal B. Therefore, the thyristors P1 and N2 are formed passed from Wt omega t is equal to 0 to omega t is equal to pi. If the thyristor P1 is turned on at omega t is equal to 0 degrees, so that the load voltage is positive with terminal and or negative. Therefore, the load voltage now follows the positive envelope of the supply voltage. At instant Wt1, P1 is forced commutated and the other forward biased thyristor N2 is turned on, so that load voltage is negative with the terminal O positive and A negative. Hence, the output voltage waveform now traces the negative envelope of the supply voltage. At instant WT2, the thyristor N2 is formed commutated and N2 is forced commutated and P1 is turned on causes the load voltage is now traces the positive envelope and at after omega t is equal to pi, terminal B is positive here. The terminal B is positive with respect to A. Both thyristors P2 and N1 are forward biased from omega t is equal to pi to 2 pi. At omega t is equal to pi, the thyristor N2 is forced commutated and forward biased thyristor P2 is turned on. At omega t is equal to 1 by 2 Fs plus 1 by 2 F naught. Here, that is the equation will be here. This is the equation. At omega t is equal to 1 by 2 Fs plus 1 by 2 F naught. P2 is force commutated and forward biased thyristor N1 is turned on. Hence, from P1 N2 are switched on alternatively during positive half cycle and the thyristors P2 N1 are switched on alternatively during negative half cycle. The output frequency F0 is higher than the supply frequency, that is F0 is equal to 6 Fs. And also here we have the few applications of cycloconverters. We have the few applications of cycloconverters that are it is applicable to where low speed and high power AC motor drives. It will be used in HVDC transmission systems, in static VR generation, and also it will be used in conversion of variable speed alternator voltage into constant frequency voltage in aircrafts and shipboards. And also it will be used in induction heating system, cement mill drives, grinding mills and rolling mills, mine winders, as well as mine host, and also it will be used in electric traction. So here today it is the summary. In summary, today class we discussed in step down cycloconverter the output frequency is less than the supply frequency, F0 less than Fs. In step up cycloconverter the output frequency is greater than the supply frequency, that is F0 greater than Fs. Center tapped cycloconverter is used for step up and the output frequency. So here and also we have the few quiz questions that are dash the circuit converts DC to AC. DC to AC is converts inverter. The applications of inverters are variable speed AC motor drives, will be used in UPS, aircraft power supplies. The answer is all of the above D. And also we have few quiz questions that are dash is the heart of the inverter, DC source, tank circuit, transformer. None is the DC source. In dash commutated inverters, an AC output of variable frequency is provided independently is the forced commutated inverters. And also we have the few quiz questions here. These are the few quiz questions for cycloconverters. And also we have the few frequently asked questions that are: explain the working of center tapped cycloconverter and explain the operation of single phase step up cycloconverter and draw input and output waveforms. So this is the today's class. Next in class we are going to discuss about the speed control of DC and AC motors. Thank you.